In this class, we're going to take a look at how you solve trigonometric equations, so trig equations for short. So I'm assuming that you've already seen the cast diagram, that you've already seen the graphs of sine and cosine and tangent. If you're not familiar with that stuff, it'll be quite difficult to solve trig equations, so I would say check those out first. So learn how to draw the sine, cos and tan graph, learn how to work with the cast diagram. If you don't know what any of that means, then look those up and check those classes out and then come back in here. Or you could just watch the examples here, but some of it might start to go into territory that you're not familiar with. So all trigonometric equations fall into different categories. So the first division is whether it's a calculator or non-calculator question. Today we're going to assume that this is your starting point with trig equations. So we're going to do these assuming you get to use a calculator. As you go further into trig, then you'll start to do questions that you've got to do manually without a calculator. We're also going to assume today that we're working in degrees, but again, as you go further into trig, you're going to move away from degrees into a measurement of angles called radians. So trig gets divided, calculator, non-calculator, degrees, radians. So the worst scenario is non-calculator and radians. That tends to be complicated, and when you first meet those, they're quite tricky. Fortunately, that's further down the line, so that's not our starting point today. So we're just going to work through these 4 examples, which are going to kind of highlight all the main issues that you'll come across when you're starting trig equations. Trig equations get a lot more complicated than this, and you'll see different varieties of these, but this will give you a starting point. So the first thing about a trig equation is that you need to have a corresponding range of values of x. So let's just assume that with this one we get our standard range, which is 0 to 360. That's one cycle of the cosine graph. This is telling us that you're allowed solutions between 0 and 360, including those endpoints. What we're going to do with this one, we're going to draw a graph, a cosine graph, just to get visualized about what we're kind of working with here. So just marking on the point 0.7. So 1, remember, is that highest point on a cosine graph. So 0.7 would be close to 1, so somewhere there. If you draw a line through the graph, where that line hits the graph, those are going to represent your 2 solutions to this equation. So the first one is somewhere a little less than 90 degrees, which is that point there. The second one is a little more than 270 degrees. And then we can just use that to visualize roughly where the solutions are going to be. The other way you can visualize your solutions is using the cast method, and we'll chat about that in a moment. But how do we actually go about solving this equation? So let me just pull the equation down here. Cos x equals 0.7. The first thing is to get the equation rearranged, so you've got cos x on one side, the number on the other. We've already got that, whereas in these guys we're going to have to do a bit of rearrangement at the start. So once you've got that, then it just becomes a calculator exercise. And the way you're going to solve these is to use something called the inverse. So if you look on your calculator, you'll find a button that says cos minus 1. That's called the inverse of cos, inverse cosine. And usually you activate that by like the shift button, and it's usually above the cos button and written in little yellow or white writing. So it's hidden on there somewhere. So cos the minus 1 of 0.7. That's how you would put it into the calculator, and then basically the calculator will just return some numerical value at that point. So this one comes out to be, because I checked it earlier, comes out to be 46 degrees. So you can tell there that that's in the correct kind of zone there. Maybe my diagram was a little off, it should have maybe been further that way, but that's fine. It's just a quick visual to make sure that it makes sense. So that's basically going to be our first solution. So we'll just kind of leave that one there just now. But we also need a second solution, this one over here, and we can get that second solution partly off of the symmetry of the graph. That would be one way to do it. So remembering that this end point on a cosine graph is at 360 degrees, that must mean that this kind of length here, which we've now figured out is 46 degrees, and this length here, they should be the same. So this point here is 46 degrees back from 360. So we're just going to go ahead and do 360 minus 46, and that will give us a second solution, which is 314. So these are basically our 2 solutions, 46 degrees and 314. So we can go ahead and assign them to x. Remember, it's x you're trying to solve for. So x equals 46 degrees and 314 degrees. So that's your two solutions. You normally get two solutions for trig equations, and that's the two solutions in that range of values. I've done that one by working with the diagram. Probably though, we want to use the cast method rather than the diagram. I did that one kind of for illustration. So the same thing on the cast method would just be, and again, if you're not sure what the cast method is, you'll need to check that out in another class and then come back in here. So if we label up a cast diagram, the way that we would work with it in terms of solving the equation, once we get our equation rearranged, this one was already rearranged, we say, right, this is a positive value. Cosine is positive in its own quadrant, in the first quadrant. So we check in those two quadrants. We did the calculator exercise and it came out to be 46 degrees. 46 is between 0 and 90, so that's fine. That validates that that's a solution. The second check is in this quadrant, the fourth quadrant. So we do 360 minus the original solution, 46, to get a solution in that quadrant. So we never use, when we're using the cast diagram, the 90 or the 270. We always get our second solution by making an adjustment from either 360 or from 180, okay? So we'll chat more about that in the next two next examples. So remember, the information from the cast diagram and the information from the graph are the same thing. It's just about visualizing it in a different form. Okay, so if that's new to you, that's going to be complicated at first, but we'll have a look at it again in this example here. So that would be the two solutions to that first equation. The second one, we're going to go through a similar thing. Let's say again that we've got a range of values 0 to 360. You cannot solve a trig equation authoritatively unless you've got a range of values, so they should always come with a range of values. So we're just going to start by rearranging the algebra here. So if we move the minus 1 to the other side, we get 2 tan x equals 1. We need to get it all the way to tan x, so dividing both sides by 2, we get 1 over 2 like that. I might just make that into a decimal. You don't have to make it into a decimal, but usually if it's going to be a nice decimal like 0.5, you might want to make it into a decimal. So what I'm going to do with this one, we're going to make our cast diagram first. It's best to make your visual first before you do the numbers, just to make sure that when you do process the numbers, they make sense with your expectation. So just firing up a quick cast diagram. Don't be too, elaborate in your cast diagram. You can just draw it quickly like that. So we've got tan equals a positive value. So we're taking the tan and the A quadrants. That means that we expect solutions between 0 and 90 and between 180 and 270. So we don't even need really the last quadrant for this one. So if we process this one on the calculator, so if we do tan to the minus 1, so inverse tan of 0.5, so that's not a value you would necessarily just know off the top of your head. Later on when you start to do trig, you might learn some of these values, and this one comes out to be 26 I think it was 26.6. Let's maybe just call it 26 for the time being. In fact, maybe 27. We'll round it up. I think it was approximately 27 degrees. Okay, so that's 27 degrees, which is between 0 and 90, which it does fit in with where our check is. Basically, if you get a number here which is not in one of the quadrants where you've checked, then something's gone wrong, or you need to make an adjustment or something like that. But basically, they should be aligned. Okay, so that's the first solution. The second solution has to be in here, so we're going to do 180 plus that first solution, and that's how we get the second one. So that would be our first solution, x equals 27. The second one will be x equals 180 plus 27 degrees, which comes out to be 207 degrees. So first solution in quadrant 1, second solution in quadrant 3. These are our two solutions. Okay, so that again, that's like basically the method. This time I used a cast diagram. I didn't draw the graph of the tan function. Generally, we are going to use the cast diagram rather than the graphs, but you can use either method. Try to go with this one. This one tends to be more efficient. Drawing the graph, unless you draw it very accurately, can actually throw your answer off a little and make you get a bit confused by it. So rearranging this guy up here for our next example, we're going to get 2 sine x equals 4, and then dividing both sides by 2, sine x equals 4 divided by 2, which is 2. Now, if you're familiar with the sine graph, which hopefully you are, let me just move my next example down a little because it's kind of getting in the way. So 2 sine x plus 1 equals 0. So if we just sketch a sine graph and see what happens with this guy here, notice that we've got sine x equals 2, but if you know the sine graph, you might already think, well, something's not right there because the sine graph has actually got a maximum value of 1 and a minimum value of -1. So if we went up to 2, 2 would be like up here somewhere, and draw our line across. Well, our line is missing the graph. It's missing the curve. It's not connecting with the curve in the same way that the line at 0.7 over here did. So what this basically tells you is that this equation has got no solutions. Another way to think of it is if you did the inverse in the calculator, so if you did sine -1 of 2, the calculator would just give you an error message. And that's quite common when you start trig. When you're not quite sure about the values, you'll end up putting things in the calculator which won't give you an answer. And rather than just knowing you're going to get no solutions, you'll just get the error. That just means the equation, it doesn't mean anything's wrong, it just means the equation wasn't solvable. And that does happen quite often in trig. Okay, so I just threw that example in to show you what could happen. So you will see quite a few error messages when you're starting off. Okay, this last guy here, so let's make our rearrangement. I'll just do this one kind of quickly. So the rearrangement would come to sine x equals -1 over 2. When it comes to be a minus, it's a slightly more difficult scenario. So let me just do the cast diagram for this one here. So we've got 0, 90, 180, 270, and then back to 360. So C, A, S, and D. So we've got sine equals a negative value. If it was a positive value, we would put our checks in the sine in the all quadrant because that's where sine is positive. If it's negative, it has to be a check in the other two. So that's a slight difference in process from what we did here. That's why we always rearrange first. Once we get it rearranged, we're just saying, is this number here positive or negative? So that one was positive. Is this number positive or negative? That one's negative. So that's what we need to take into account when we're drawing the cast diagram. The other change in process is when we come to do our, we'll maybe just call that minus 0.5. When we come to do our inverse, you drop the negative, okay? So it's going to be sine inverse of just positive 0.5. That's just part of the process. As you get further into trig, you'll realize why you need to do that. So that, if we process that in the calculator, we would get 30 degrees. But notice that 30 degrees is in this quadrant, the A quadrant, where we don't have a check. So that tells us something's not quite right. All that it means is that this here is not one of our final solutions. It's just like a reference angle that we're going to use to get to the solutions. So basically, when you're dealing with a negative, you've got a bit more work to do. You've got an extra 2 or 3 steps in the process. So what we're going to do is take our adjustments now off of 180 and 360. Again, we're kind of discarding these two, and we're going to get our solutions as x equals 180 plus 30, which is 210 degrees. That's the first solution, and then x equals 360 minus 30, which is 330 degrees. Just to go back to the diagram for the sine graph, so we had sine x equals negative a half, so negative a half is in here. If we draw our line across, it should be that where the graph is estimating those solutions fits in with these. So if we just check that out, so this point here, the middle point is at 180, so that solution there, 210, that fits in really well. This end point is 360, so that second solution just a little bit short of that, 330, again, that fits in really well. So whether you use the cast diagram or the graph of the function, or even if you can sort of visualize those in your head and you don't need any of them, which some students do, then just running through to get the solutions, everything should be consistent. There shouldn't be a piece of information from one of these sources which doesn't fit in with the others. Woo, so quite a lot going on there, right? It's not easy. Trig equations are difficult at first, and just a lot of skills being pulled together. So make sure the absolute keys you need to make sure are that you know how to work the cast diagram, that you know how to draw the graphs, that is really an important skill as well, that you understand the range of values, that you practice with this inverse thing on the calculator. That's going to be all new at first. It's a whole bunch of new skills and you're pulling them all together and trying to piece them together into a process that makes sense. Some of them will come out to be positive values here and you just flow through like that. When they come out to be negatives, you've got more work to do. So maybe recheck this example, make sure that made sense to you. They're more difficult, those ones. They tend to be the ones which at first students will make mistakes on and get a little confused. And that is perfectly normal. You should almost expect that because it is difficult. You're trying to piece together a lot of information. So maybe rewatch this class. Trig equations are an important course. They come up in a whole bunch of other math topics, and definitely check out quite a few practice questions on this technique.